So today we've got properties of parallelograms. Kind of objective for today is to use the properties of parallelograms to find missing sides, missing angles, and parts of the diagonal. So we're going to start out by going through just the properties of parallelograms. We talked about parallelogram in the past. Remember that a parallelogram is a quadrilateral. Quadrilateral means it has 4 sides. Quad means 4. Lateral means side, so 4 sides. So a parallelogram is a 4-sided figure with opposite sides parallel. So that's the first part of the definition. Opposite sides are parallel. So if we look at this parallelogram, opposite sides means sides that are across from each other. Quadrilateral, it's got to be a closed figure. So those 2 pieces are going to be parallel to each other. And then these 2 sides are going to be parallel to each other as well. So that's the first thing. Parallelogram, opposite sides are parallel. But it also has other special properties that we have to keep in mind, and that's what we're going to talk about next. And we're just going to go ahead and draw them right on our drawing today. So the first thing we already did, opposite sides are parallel. I've already marked the sides as parallel to each other. The next piece of it is that opposite sides are congruent. So opposite sides are congruent means, okay, well, I can not only say that opposite sides are parallel, but I can put my tick marks there. So those sides have to be congruent to each other, and these 2 sides have to be congruent to each other. And again, remember what that means. If they're congruent to each other, it means they have the same length. So if this has a length of 10, this has a length of 10. They're the same measure. If this has a length of 30, this has a length of 30. They have the same measure. It doesn't matter what I put in here. If I put in here that this is x plus 10, this side also has to be x plus 10 because they're congruent to each other. So that's the first property. Opposite sides are going to be congruent. The next property, opposite angles are congruent. So not only are opposite sides congruent, but opposite angles are congruent as well. So this angle, and I'm going to go ahead and name the angles AB, we'll call this one C and D. Angle A and angle C are opposite of each other. They're the furthest from each other. They don't share a side. When we're talking about opposite, remember it means they don't share a side when we're talking about opposite angles. So angle A and angle C are congruent to each other, and angle B and angle D are congruent to each other. Now notice they're not necessarily congruent to themselves. In some parallelograms, we're going to find out that they are, but not in all of them. In all parallelograms, they're congruent. They're not all equal to themselves, but they are congruent to each other. So again, if this is 40 degrees, angle A is 40 degrees, angle C is 40 degrees. If angle B is 140 degrees, angle D is 140 degrees. They're going to have the same measure. If this is x plus 10, if this is x plus 10 and this is 30, then x plus 10 has to equal 30. And we'll do some problems like that here in just a little bit. But opposite angles are going to be congruent to each other. The next one's kind of, well, they're all kind of important, but this one kind of doubly so. Consecutive angles are supplementary. So let's break this down a little bit. Consecutive means they share a side. Okay, opposites angles don't share a side. Consecutive angles share a side. Consecutive angles are going to be supplementary. So angles that share a same side are going to add up to 180 degrees. So if we look at what we have, angle A and B share a side. So since angle A and B share a side, angle A plus angle B has to be 180 degrees. They're consecutive sides. Angle B and angle C are consecutive sides. So angle B plus angle C has to add up to 180. And now I think you can kind of see how it's going. That means C and D are consecutive angles, so they're going to add up to 180, and A and D are consecutive angles, so they're going to add up to 180. So angle C plus angle D equals 180, and angle D plus angle A also has to equal 180. And we're going to do examples of all these properties here in just a little bit. And if you noticed in that first, if you kind of rewind the video a little bit, before I said that these two were 40 degrees, and I said that that's 140 degrees, making that 140 degrees. Notice that's 180, that's 180, that's 180, and that's 180. So consecutive angles are supplementary. The last property that we have to talk about talks about the diagonals of a parallelogram, specifically that the diagonals of a parallelogram bisect each other. So a diagonal would be something from A to C. Diagonals go from opposite angles. Okay. B to C is another diagonal. Now it says they bisect each other, so that means they cut them into two congruent parts. So the distance from B to, let's call this E. That's E right there. The distance from B to E is going to be congruent to the distance from D to E. And the distance from A to C is congruent from E to C. And again, notice they're not congruent to each other. They're not all congruent. They just have to bisect each other. Are there parallelograms where they're all the same? Yes, there are. We'll talk about those at a later date. So those are our 5 properties of parallelograms. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. So let's look at a couple problems we have. We're going to jump past that one. We're going to go right to these. So we're going to find the measure of the indicated angle. So the first thing I'm going to do when I look at these is I'm going to try to figure out, okay, let's first determine what they are. We know it's a parallelogram because it says for each parallelogram. So all of our properties are going to hold. The 2 angles that I'm looking for are right here, R and S. Those are my 2 given angles. I have to find R given that S is 140. Well, those 2 angles share a side. Sharing a side means that consecutive angles are supplementary. So X plus 140 has to equal 180. Consecutive angles are supplementary. So if you add those 2 angles together, they have to be 180 degrees. Solve the equation, and you get 40. Must have subconsciously did that one in my head. Okay. Number 2. Number 2, we look at it, and we look at what we have, and we've got opposite angles. Our property for opposite angles are congruent. So if angle V is 45 degrees, that angle also has to be 45 degrees. And you're done. Okay. Could we find Y and W? Sure could, but they didn't ask us for it. Only ask what we're looking for. Number 3. Again, I'm looking with what we got. This time we have to solve for X, the figure of the parallelogram. So we're given Q and S. Q and S are opposite angles, and opposite angles are congruent. So if opposite angles are congruent, that means that their measures equal each other. How do I know it's a measure and not a length of a side? That degree symbol, technically speaking, that should probably look like that, but our worksheet didn't do that. So they equal each other. So we subtract 7 from both sides. 4x equals 48. Divide by 4. You get x is equal to 12. And you could plug 12 back in there to make sure it works. 4 times is 48. 48 plus 7 is 55. It works. Number 4. Again, I'm going to look at what I've got. These 2 right here. Well, they share side BA, so that makes them same side. Same side. They're consecutive angles, mean that they're supplementary. So when they're supplementary, it means they need to add up to 180. 5x, combine like terms, plus 140 equals 180. Subtract 140 from both sides of the equation. 5x equals 40. We get x is equal to 8. Mathematically, think about it. These 2 lines are parallel, cut by a transversal. Same side interior angles are supplementary if 2 lines are parallel. Anyway. All right, so that was angles. Now we're going to talk about sides. Remember, opposite sides of a parallelogram are congruent. Those are opposite sides. They don't share an angle. So pretty straightforward. That one's 24. Opposite sides are congruent. That has to be 12. And those are your solutions. Those are pretty quick. And these aren't too bad either. As long as we're looking at sides, we know they're congruent to each other. We're looking at sides. I know they're sides because they don't have degrees to them. So opposite sides are congruent. So 2x plus 3 has to equal 11. Subtract 3 from both sides, sorry. X is equal to 4. And I'm going to go through, sometimes I go through and solve the equations a little bit quick. It's the algebra. Hopefully you can do the algebra. And the last one, again, we've got opposite sides. Opposite sides are congruent. So 4x minus 1 equals 3x plus 1. Again, kind of goes by the concept that I always use for geometry. Concepts don't change. The difficulty of the algebra does. Up here it was quite easy. Just had to do what it was. Number 7, you had one variable on one side of an equation. And now we've got one variable, but now on both sides of the equation. So the algebra gets a little bit harder. The concept doesn't change. We subtract 3x from both sides. Now we've got rid of our variables. Now we add 1 to both sides, and 1 plus 1 is 2. So there is looking at that piece of it. All right. Might as well do it in alphabetical order. Find x first. What's my equation to find x? 4x plus 8. Does it equal it, or do I have to add it together to set equal to 180? Equals 5x plus, I think that's a 1. Looks like an I, but we'll say it's a 1. So I'm going to subtract 4 x's because I like my x value to be positive. Subtract 1, you get 7. I almost messed that up. 7. Questions with that one? If I look at my angles, how do I know they're angles as opposed to sides? They've got this little degree symbol right here. The degrees tells me it's an angle. The angles share this side. So if they share a side, are they equal to each other, or do they add up to 180? They add up to 180. So 3y plus 9y minus 12 has to equal 180. So there's our equation. Combine like terms. 3y plus 9y is 12y. So 12y minus 12 equals 180. Add 12 to both sides. Hello, this is Tony. Yep. We certainly will. Yep, but. So 12y equals 192. Divide by 12. Somebody with a calculator? 16 is our solution. Are there any questions on any of the examples that we did today? So your whole goal today is going to be to find the values of x or y, given just the properties that we practiced today. We didn't practice one of the properties. We didn't practice what happens if they're the diagonals. Okay, we're going to practice those tomorrow. When you get your sheet of paper right now, it's going to have the diagonals one on them. You don't need to do any of the questions that have diagonals. You're only going to do up to. So the last thing we want to look at with the parallelograms, we talked about congruent sides, and we've looked at examples of congruent sides and congruent angles. Now we're going to look at some of the examples of parallelograms. Just remember from our definitions that in a parallelogram, the diagonals bisect each other. It means they cut them into two congruent pieces. So these two parts are congruent to each other. Let's make this a little skinnier. And these two parts are congruent together. So let's look at our first question. The first question says UW is equal to 10. So, I'm sorry, xw is equal to 10. So I'm going to put that this is 10. Well, if I know this is 10, I'm not even going to look at what the next question is, but if I know that's 10, I also know that this is going to be 10. So I'm just going to go ahead and write that in there. It also tells us that uw, this whole thing, is x plus 10. Okay, so we have to find the value of x. Now let's logically think about it. I know the whole thing is x plus 10. That's what it tells us in this part right here. But as I look at my diagonal, it told me that wx was 10, and because of that, xu had to be 10. So that 10 plus 10 is 20. So that whole thing has to be 20. So I can find my x by subtracting 10 from both sides, using the properties that we know, and then a little bit of logic. Question number 2, UW is 19. So UW is 19. So I'm going to put a 19 there. So I'm going to go ahead and put a 19 there as well because they have to be congruent. This time it says that UY, that distance right there that I just highlighted in blue, and now I'm going to highlight it in red, it also tells us that that is x minus 1. Well, so you got two things equal to the same thing. So therefore, 5x minus 1 has to equal 19. Add 1 to both sides to solve the equation. You get 5x equals 20. Divide by 5, or think 5 times 1 is 20. 5 times 4 is 20. There's your value. Drawing on your example problems is the best way to do these. 2 more. Number 3. Number 3 says SD is 21, so I'm going to go ahead and put a 21 there because it's a parallelogram. Then SF has to be 21 as well. In this question, it's telling us that FD, this whole thing, is 2x plus 42. Well, if the whole thing is 2x plus 42, and we know if we add 21 and 21 together, 21 plus 21 is also 42. So 2x plus 42 has to equal 42. Subtract 42, kind of gave a little giggle there because I know what's going to happen. 2x equals 0. 2 times what is 0? X is equal to 0. They just kind of solved that one for us, made that one nice and easy for us. And the last one. EG is 36. Ooh, so now it's this whole thing. So this whole thing is 36. So if the whole thing is 36, then I can find the part that I labeled in red and the part that I labeled in purple. They have to be the same. So if they have to be the same, that's the same thing as taking 36 divided by 2, which is 18. So I know that that's 18, and I know that's 18. Don't know what the question is yet, but we'll figure the question out in a bit. Question says SG is 10x, so that is also x plus 10. Well, if it's x plus 10 and 18, x plus 10 must equal 18. Subtract 10, subtract 10. X is equal to 8. So hopefully looking at those examples gave you a good spot on how we use the properties for parallelogram when we're given the diagonals. Remember, the diagonals are congruent.